Did you know? Stroke is currently the second leading cause of death in the world. Around 6.8 million die every year. One of the challenges is that stroke is usually treated through the rehabilitation programs, which are considered to be boring and discouraged by the stroke patients due to its repetitiveness. Meanwhile, low accessibility in rural areas and unaffordable price to undergo the private physiotherapy session and fMRI also restrict the impoverished ones from getting regular stroke rehab and scanning. However, according to Stein, a physician under the Department of Rehabilitation Machine of Columbia University's College, repetitive exercising is the key to stroke rehabilitation. Hence, a repetitive yet sustainable rehabilitation machine with the integration of economic stroke recovery quantification system is concerned. We name it the Combined Upper and Lower Limb Stroke Rehabilitation Machine System, CULSRMS. This system basically comprises 4 subsystems, which are a rehabilitation system, sensor measurement system, EEG monitoring system, and stroke recovery prediction system. The features and functions of each system will be discussed in this demonstration session. During the rehabilitation process, patient will be directed to a seat with the LLSRM. Before beginning the exercise, physiotherapists will ensure that the patient feels comfortable with the current setup. After patient settles down, the Emotive Epoch Plus headset will be worn by the stroke patient for measuring brain activities. Next, all head nodes are ensured to turn to green color for good contact quality through the Emotive Savior control panel. Thirdly, the activity type will be selected for the aim of classification of different activities. Open eye calibration is done afterward, followed by closed eye calibration to remove unwanted artifacts. Continuous passive mode CPM or active resistive move ARM can be chosen by the physiotherapist via a developed GUI using LabVIEW. The choice of mode depends on the strength of the paretic lower limb of the stroke patient. Patients who have totally lost their strength of the paretic limbs will undergo CPM exercise. Meanwhile, patients with mild lower limb stroke will undergo ARM exercise. Besides, physiotherapists can modify the threshold value from time to time depending on the muscle strength recovery of the patients. Before carrying out rehabilitation exercise, a live matrix recording is started to capture the real-time engagement level. When the live matrix measurement is initiated, the patients will be subjected to various motivational factors to measure their engagement level in each activity. The aim of this test is to investigate the effect of different motivational factors on the engagement of the stroke patients during rehab exercises using EEG obtained from the measured signals of the brain activities to create an optimized model. Later, a report of measured live metrics will be generated and displayed in percentage form. A bar chart of engagement metric versus motivational factors is plotted in SAS Visual Analytics. The factor that yields the highest engagement metric will be regarded as the effective motivational factor for the specific patient. For example, in this case, patient experienced the highest engagement metric while playing Pong game. This indicates that Pong game can help patients to be more engaged during the rehabilitation, and hence strengthening the neuromotor pathways. At the end of the rehab exercise, physiotherapists will proceed with the EEG measurement of the patient with the Emotive Epoch Plus device. Once the EEG data is recorded for 2 minutes, physiotherapists can run the MATLAB GUI to measure the EEG brain beta coherence index as an indicator of brain functional recovery. Eventually, the measured data such as patient's details, force readings from the machine, EEG beta coherence index, response time and engagement level are stored in an Excel file for further process. Doctor can then import the Excel file into our stroke recovery prediction model via SAS Studio to get scoring on the percentage recovery of the stroke patient in regaining their strength. The outputs which determine the recovery of the stroke patients are the input force difference and the final beta coherence index. The smaller the input stroke difference between two legs, the higher the recovery of the strength of the paretic limb. Meanwhile, the higher the beta coherence index, the higher the brain connectivity between regions, and hence the higher the recovery rate of the stroke patient. After exploring our system, how can it actually impact our society? At first, it promotes relaxed and highly engaged rehabilitation process with the introduction of motivational factors, and in the meantime, allowing the robust indication of the stroke recovery rate, which will encourage the stroke patients to exercise more. Besides, hospital can choose to rent or purchase this product at low price point, which will in turn increasing the accessibility towards the society.